Hello and welcome back to my channel. My name is Rai and today we're going to continue our journey in C programming for Linux users. In our previous video, we simply compiled our first C program and did nothing but print a string onto the stream. In this video though, we're going to take a look at more examples and we're going to make our program interact by taking inputs from the user. As always, I'm bringing you bite-sized video tutorials on programming and technology that are easy for you to digest. So if you're new to the channel, please subscribe and hit that notification bell so you don't miss out when my next video comes out. Alright, so let's go straight ahead to our next example. First, open up a terminal and change into the directory that we've created before, cd_camp. I'm gonna use Nano Text Editor this time, which is a lot more beginner friendly as this tutorial is actually aimed at complete beginners. However, if you're interested in learning Vim, the text editor that I used in the first video, you can type Vim tutor on the terminal and it'll give you all the things that you need to know on how to use Vim. If you don't have Vim installed on your system, you can easily install it by typing the command sudo apt install vim. I already have Vim installed, so I'm gonna cancel that. So our next example is gonna be all about variables. So on the terminal, I'm gonna open a new file named variables.c with nano. Let me just make my terminal bigger. Variables.c. On our first line, let's type in our header like before, hash include standard io.h, and then on the next line type int main. Again, this is our main function which serves as an entry point when our program is called, and the int keyword, which stands for integer on the left, is the return type when our program exits. This is because we always need to return an integer to the calling program to signal success or fail. This is known as the exit status. Returning 0 tells the operating system, which is the calling program, that everything went okay, while returning 1 means something went wrong. Now we can create an opening and closing curly braces, and then our main code goes within these curly braces. So to create our first variable, type in the following. I like to use spaces instead of tabs in indenting my code, but that's just a matter of personal preference. Int number car letter. Just remember to end them with semicolons. Now think of variables to be like boxes where you can put values inside. In C, before we can put values or assign anything into our variables, we have to declare it first with its variable type on the left, right there. In our case, we declare number to be of integer type and a letter to be of character type. You can actually name your variables into something else other than number or letter, but it should be meaningful, like for example my favorite number, or my favorite letter. Spaces and hyphens are not allowed, so you can use underscores instead. You can also name your variables using camel case, where the words have no spaces and each word starts with a big letter except for the first word, like so. My favorite letter. You can even name your variables as simple as a single letter like N or L. Int N car L. Alright, so let me just undo this. So to actually assign something to our variables, we can use the equal sign operator. For example, number equals 17 and letter equals C. This assigns 17 to our number variable and C character to our letter variable. Please take note that character C should be enclosed with either a single or double quotes. Now on the next line, type in the following: print f, then our string, Sesame Street was brought to you today by the letter modulo C and by the number modulo D. Then new line character, then close your string, letter, number, then semicolon. And then of course our last line would be our exit status, return 0. Now save your file with Control O, then press Control X to exit. We can then now compile our source code variables.c using GCC, just like before. So GCC-O variables.c. If you get a compilation error, edit your source code and check that you have typed everything correctly. It's also a good thing if you read what the error says. Like for example, let's say I forgot to put a semicolon at the end of my printf statement. Let me just extend this again. I'm gonna delete the semicolon, save it, Control X. Now if I try to compile it again with GCC variables.c, and then I get this error. This is actually a good thing because as you can see, the compiler is telling me exactly what's wrong with my code. The compiler is complaining of a missing semicolon before the return statement, and it's telling me exactly what line number and what column to check. Alright, so now let's clear that, and now let's try to run our program. That's /variables, and we get this nice message printed on our screen. Sesame Street was brought to you today by the letter C and by the number 17. Now let's go back to our source code and look closely as to what is actually happening here. So basically, when we run our C program, our main function gets called and it executes our code line by line. So here, as we've already discussed, we declare our variables, and then below we assign values to them. Then inside our string, we have what are called format specifiers, and they are the modulo C and the modulo D within our string. The printf function recognizes them and replaces them with the corresponding value of the arguments given to printf after the string in the order to which they were given. In this case, it's our variables letter and number. The format specifiers tells printf what type of data our variable contains, and modulo C simply means character, while modulo D means decimal or assigned integer. Now our program seems to be a bit boring because all it does is print the same message onto the screen every time it's executed. The message is static and does not change. What if we wanted to print, let's say, a different letter and or number? Then we have to edit our source code first and change the values of the variables, like for example 23 and then the letter F save it, and then recompile it before we can see it printed on the screen. Now there must be a better way of doing this without having to go through all that trouble, right? The answer is actually yes. We can actually make our program or C program dynamic and interactive by letting the user choose the value our variables must contain during runtime. So we can create another file called input.c. Let me just close this. Nano input.c, and type the following. On our first line, of course, we have our header, hash include standard io.h, and then our main function int main, and then the open and closing curly braces, which will contain the body of our function. Again, let's declare our variables. Like I said, you can name your variables pretty much whatever you want with the exemptions that I have said earlier. And also, I forgot to say this, if it's not a reserved keyword or a C reserved keyword. All right, so for a list of C reserved keywords, please see the description down below. For now, we're gonna name our variables the same as before. 1 2 3 4 car letter int number. All right, so now type the following. Printf, what is your favorite letter? Question mark, semicolon, then scanf modulo C, then end quote, ampersand letter, semicolon, printf, what is your favorite number? Question mark, end quote, semicolon, then scanf modulo D, end quote, comma, ampersand number, semicolon. Then printf, then our string, today's show was brought to you by the letter modulo C and by the number modulo D. Then new line character, end quote, comma, then letter, comma, number, then close parentheses, and then semicolon. Lastly, return 0, our exit status. We can now save this file, Control O, and exit nano, and then compile it with gcc-o input.c. Now try running our executable ./input, and it'll ask the user to enter his or her favorite letter, R, and number 23, and print them on the screen. Alright, so let's go back to our source code and go over our code. So the first line, we already know our preprocessor directive to include our standard library so that we can make use of the printf function. The next line of code is our main program, or main function, I should say. And then the next two lines would be the integer and the character variables declaration, which corresponds to a space in the memory of the computer that are allocated to hold the values. The user is then asked his favorite letter using our printf function. Then the program waits for input from the keyboard. The input is read from the keyboard using the scanf function. The character code modulo C tells scanf to read the character from the keyboard. The character is written into the memory allocated to the letter variable by passing the memory address of the letter variable, which is accessed via ampersand letter. The next two lines are just the same thing for our number variable. Notice though that we used modulo D character code to denote an integer input. The letter and number variables are then written back to the screen using our printf function here. The last line is of course our exit status. Remember when I said that it's always a good idea to comment your code, and if you noticed I haven't placed any in my code, well, you should, so I'm leaving it to you as an exercise. Okay, so that's it. That's all I have for this tutorial. I hope you enjoyed it. If you did, please give me a thumbs up and share it with your friends. In our next video, we'll make our code reusable by writing our own function and also touch up on how to control our program flow. So yeah, thanks for watching and see you in the next one.